Here's a video about objects sliding along a level surface here. And what we know is that there's a 20 kilogram box sitting on the floor. That's what this is supposed to be, the floor, right? Just practicing writing here, right? Let's just first talk about some of the forces that are acting here. This 17 newtons here is presumably the force you would need to slide this thing along horizontally at a constant speed. So if I pull on it this way with 17 newtons, right, this is my force applied. Okay, then what that means is that there'd be a force of friction the other way, right? This 17 newtons, you'd have a 17 newton force of friction, right? Okay, so the friction force would be acting to the left, the applied force would be acting to the right. So the thing would actually move at a constant speed. In fact, that would be how you'd find the force of friction, is that you would just find whatever force you needed to drag it at a constant speed. Now that wouldn't be the only force acting on this, of course. There's still the force of gravity pulling this thing down, right? And that force is going to be the weight, right? And the weight is equal to m times g. So 20, right, times 9.81. This is kilograms, right? And this is 9.81 newtons per kilogram, right? And that is, well, 20 times 9.81 is 196.2. Okay, so that's the force of gravity, right? Okay, so gravity is going to be pulling down on this thing, and I can't even draw this long enough. It needs to be like more than 10 times longer than that, but I'll just draw it good and long, right? There's our 196.2, right? And that's gravity pulling down. This surface, though, the floor itself, so this is gravity, right? The floor itself is going to exert a force. You see what gravity does is it acts on every particle of this. Ultimately, though, this surface here is exerting some kind of electrical force or something, the electrons pushing against the electrons in the floor, right? Ultimately the floor is going to push back, assuming it doesn't break, right? Not all floors can push as hard as other floors. Now these forces are going to be equal, right? These guys, if it's moving at a constant speed, are going to be equal, right? And then that force up is also 196.2, right? So the gravity pulls down, the floor pushes up, and this is also known as the normal force, okay? So there it is, moving at a constant speed. Now if the force is less than 17 newtons, it's going to decelerate, and if it's more, say it's sliding to the right, let's assume it's moving to the right, okay? If the force is more than 17, then it's actually going to go faster and faster. So let's look at one of those problems, okay? Okay, so there's a 17 force of friction between this box, and if it's sliding to the right, and I exert a force of 78 newtons to the right, so this thing is moving to the right, okay? There's 78 newtons to the right, right? So there's 78 newtons, okay? But the force of friction, if it's sliding to the right, friction just opposes the motion, right? So that friction force of 17 newtons will be that way, right? I'm going to make to the right positive, and to the left negative, okay? And so to solve this one, of course, we don't want to forget this force here. There it is, it's negative, this guy's positive, right? And all of the forces, and the formula I'm using here is just F equals ma. But F can't be just one of the forces, it's got to be all the forces, right? So the forces are the friction force, so negative 17 newtons, right? Plus the applied force here of 78 newtons, right? And that's all the forces, right? And then that equals 20 times A, right? And then we can solve for A. 78 minus 17 is 61. 61 divided by 20 is 3.05, right? Meters per second squared. And then the question is, how do you round that? And the convention is maybe that you round up, I don't know, 3.1 meters per second squared, right? Right? Just don't forget the friction, right? The friction is impeding the acceleration. The applied force is promoting it, right? Let's do another example here. So that's solving for acceleration. Sometimes we know the acceleration, right? Okay, we know the acceleration, and we want to find out what the force is, right? Okay, so let's see. It's sliding to the left. So this thing's sliding to the left, which means, by the way, the friction force will actually be opposing that, right? Little friction force, 17 newtons, will be actually to the right. Okay, I'm going to guess that there's probably an applied force that will actually be to the left here, but we don't know that yet, right? This is an unknown force problem, so we coyly pretend we don't know which way it is, right? So here's some unknown applied force, right? And then we know that it's accelerating to the left, right? So that's going to make this a negative acceleration. So not only is it sliding, our velocity is to the left, but our acceleration is also to the left. So it's accelerating in the direction of this applied force, and it's going faster and faster. So that force must be to the left and bigger than 17, right? So our acceleration is negative 2.3 meters per second squared, right? So now we're all set. This guy is going to be positive. Even though we know that's a negative force, we coyly pretend that we don't know, right? And we go, and we're just using F equals ma, right? Where F is the sum of all the forces, right? So we have unknown force, right? Plus 17, okay? And I made that plus because so we know if it's sliding to the left, the friction is to the right, okay? And then that equals 20 times, and then this acceleration is to the left, negative 2.3, right? And now we're set. We're going to go this times this, and then we're actually going to subtract the 17. Okay, so we go 20 times negative 2.3. I get negative 46 plus negative 17. Right? And I get negative 63. So the force is equal to negative 63. Well, what does negative mean? Well, negative means we made everything to the left negative and everything to the right positive, right? Okay, so the negative just means to the left. Okay, so we would say 63 newtons to the left. Yeah? Yeah? Okay, and then let's do another one. And this next one's just going to be a Suvat problem, and we'll end up with, I'll show you this, right? So we've got, it's moving 6 meters per second. It slides to a halt in 15 meters. And then what other force must be acting on the box? All right. Okay, so it's sliding to the right. It's moving to the right. If it's sliding to the right, that's the velocity, right? Then the friction force, this guy here, must be to the left. Okay. So I'm going to say there's 17 newtons that way, right? And then this thing slides 15 meters. Right? So S equals positive 15 meters. The initial velocity is, 6 meters per second? Right? And then the final velocity is 0. Okay? So the first thing we're going to do is we're going to solve a cute little Suvat problem, right? Okay, our initial velocity is positive 6 because it's to the right, yeah? We're using the same convention. Everything to the right will be positive, everything to the left will be negative, right? Okay, our final velocity is 0. Our displacement is positive 15. Okay, and then of course the thing I'm going to use is v squared is u squared plus 2as. Okay, that's supposed to be a u, not a backwards n, right? Okay, and then what is it? It's 0 squared equals 6 squared plus 2 times a times 15. Right? So it's going to be, we put the 6 on this side, so it's negative, right? So the opposite of 6 squared divided by 2 divided by 15. And I get that the acceleration is negative 1.2 meters per second squared. And then we just take this, right? And we cross the blood-brain boundary there, something there. Okay? The blood-brain barrier. And we're going to use that in a little F equals ma equation. So let's set up our forces. F equals ma. Our unknown forces are, F, right? And the 17. This guy, since it's sliding to the right, the friction force will be to the left. Okay? And then we've got this force, the unknown force. So that's all we have, right? We got force minus 17, okay, equals 20 times negative 1.2. So yes, indeed, because it's negative, it's actually decelerating. We've got to make it negative again, right? So 20 times negative 1.2 is negative 24, and then I'm going to add 17. And I get that the force is equal to minus 7.0 newtons, right? The minus sign means it's to the left, right? So we'd have to say 7.0 newtons left. That's the direction of it, right? Because there it is, right? So what that means, by the way, is that it actually decelerated faster than friction would have done it alone, right? The friction would have decelerated at 17 divided by 20, which is actually just 0.85 meters per second squared. But here it's accelerating even faster than that, so it actually needed help, right? It's sliding to the right, and the forces are actually 17 to the left and 7 to the left, right? Whatever it is, right? It could be you know, miniature dachshunds or something pushing to the left. I hope that helps.